Good day, class. My name is Bashir Ibrahim, and today's class I'll be talking about regression analysis. So the term regression was coined by a man called Francis Galton, and his aim is just to find the dependency on the height of the parent and their child. So in 19th century, and it's just to find the dependency on the height of the parent and their child. And at the end of the research shows that the tall parent are likely to have a tall child, and the short parents are likely to have what? A short child, right? So regression analysis talks about the dependency, the relationship or dependency of, it shows the relationship between the dependent variable and one or more independent variable with the aim of forecasting or predicting the dependent variable given the fixed value of what? Independent variable. I repeat, the regression analysis shows the relationship between the dependent variable and one or more independent variable with the aim of forecasting or predicting the occurrence of dependent variable given the fixed value of what? Independent variable. And regression analysis is divided into two. Regression is divided into two. We have simple regression, and we have multiple regression. Class, when we're talking about the simple regression talks about the relationship between one dependent variable and one independent variable with the aim of getting, the disparity, with the aim of getting to predict or forecast the occurrence or the outcome of the dependent variable given the fixed value of independent variable. And when we are talking about the multiple regression analysis, it talks about a dependent variable and two or more independent variables with the aim of forecasting or predicting the outcome of dependent variable given the fixed value of what? Independent variable. And another name for simple regression analysis, we call it a bivariant. We call it bivariant. And another name for multiple, we call it a multivariant variable. It's a multivariant what? Variable. So how do we analyze or estimate the parameter here? How do we estimate the parameter here? So this same introduce this to be the population. We have beta naught plus beta 1 x and error term. Now, he called this to be population regression what? Function. Derivation of the parameter or the estimate of the regression analysis. So he called this to be the population regression function, and we have the one with cap to be sample regression what? Function. Class, this is the population regression function. Why this is a sample regression what? Function. According to him, the one with cap. And if you look at what we have here now, the y and x is a variable. And this is a sample of simple regression analysis, because the analysis that we have here talks about the dependent variable y and independent variable what? X. And this beta naught beta 1 is a parameter estimate. It's a parameter estimate. And what we have here is known as error term. It's known as error term. So error term is just to capture all other variables that can affect the dependent variable, but we don't consider them. We don't consider them. Let's assume this y is the consumption pattern of the consumer, and the x is the income of the consumer. It is not only the income of the consumer that determines the expenditure of the what? Of the consumer. But when we consider the x to be the income and we add all other variables constant, so we call those other variables that can also affect the consumption pattern or the expenditure of the consumer aside from the income, but we add them constant to be what? Error term. So we use the error term to capture all other variables that can affect the income of the consumer. And now we see to estimate that parameter, we sum and square the error term, then differentiate with respect to what? The beta naught and beta 1. We sum and square the error term, then differentiate with respect to what? The beta naught and beta 1. And this is the process for only simple regression what? Analysis. For only simple regression analysis. So by doing that, and please remember that the analysis here or the process here, we help the econometry what? Student who, if you study econometry, there are some analysis or the points that I'm going to be mentioning here for you to know that, oh, if I'm to find this, this is a step involved. If I'm to get it, this is a step involved. So now, you sum and square the error term. Then, let's write it in Word first, class. So let's say sum and square the error term, then differentiate with respect to beta 1 cap and beta naught cap and beta 1 cap. So how do we do it, class? How do we do it? You know, we call this to be the population regression function, and we call this to be sample regression function. And as we know, nobody can carry out the research on the entire population. Nobody can carry out research on the entire population. But what we do is to extract the sample from that population, and the result you are getting can be used to justify the outcome of that population, right? So now, how do we do it? So we say that to estimate this, we can say the population minus what? Minus sample. Population minus sample. So to apply this now, sum and square the error term, then differentiate with respect to beta naught and beta 1. In some textbooks, you can have a beta 1, beta 2. And sometimes instead of using beta 1, they can use alpha or any other letter. Please take note. So to do this, you can say that let's sum and square. Then we try to differentiate this and this. Then we square this. Then we square this. Class, everything that we have here is representing the beta y cap, right? So I can rewrite this to be summation u this over y minus beta naught cap plus beta 1 cap x, right? Everything what? Square, class. So it's just like replacing what we have here with this. So now let's expand this bracket with this sign. So I can also rewrite this to be, square y minus beta naught cap beta 1 cap x square. Class, what we have here is known as OLS criterion. The method we are using here, it is called OLS what? Method. It's called OLS method, ordinary least square method. It's called ordinary least square method, right? So, and is one of the important method and is most used method in solving the what? The regression analysis or to obtain the parameter formula, right? So we call this to be the what? OLS criterion. So from OLS criterion now, let's differentiate with respect to beta naught and beta 1. So in differentiating with respect to beta 1, u square beta 1 cap, right? So if I'm differentiating with respect to this class, you have minus 1. Then repeat what you have inside bracket the way it is. That's the rule of differentiation, right? Chain rule. Then we say this beta naught cap minus beta 1 cap x. Then multiply by the power 2 and remove the power by what? By 1. Remove the power by 1, then equate to 0 at FOC, the first order what? Condition. Now, let's multiply this with this. I have this minus 2 summation of beta y, beta naught cap minus beta 1 cap x. Then 2 minus 1 is 1 is equal to what? Is equal to 0, right? Now, our intention, we don't need this minus 2 there, right? So we can say divide both sides by what? By minus 2. So you can say divide both sides. Divide both sides by minus 2. So at the end of the day, we have summation y minus beta naught cap minus beta 1 cap x is equal to what? Is equal to 0, right? So let's expand what we have inside bracket with this summation, right? So in expanding the summation with this,